So it looks like we've got a small group. Hopefully some other folk will join in here shortly. But I'm going to go ahead and get started. Let me share my screen with you. So I have been posting regular announcements, and also after each class meeting, I've posted the recording. I will post the recording for this class as soon as class is over and the system generates a link and sends it to me, so that if you want to view the recording, you have access to it. And also, if there's any occasion where you miss class, you can always go back and view the recording to get caught up. In addition, I always put a link to the recorded class meeting right in the weekly overview. So the recording for this class will be available in the weekly overview as well. So you have access to our class meeting in more than one location, and you can, view the video at your convenience for whatever purpose it might serve for you. I will say to you, if you have any challenges with getting the videos to open, please let me know right away. I have been working with IT to make sure that we resolve any of those types of issues. I went into all of the videos that I've recorded and set the permissions so that as long as you log in with your RPCC email and password, you will be able to access those items. Any questions on that? Okay, so I'm going to go ahead and cover the items for this week so that you know what you have on your plate as far as the new experiments. So this week, you had until 6 o'clock today to get me your lab report for gravitation. Don't forget that the PostLab, the item that we would normally do in class, is now being done as a discussion. And so your responses for the Gravitation PostLab are due by 11:59 p.m. on this Saturday. And you basically just click the link for the PostLab and you record your answers. And if it asks you to respond to your classmates, then that's what you have to do. So you see, this one does not tell you specifically that you have to respond to classmates. So all you have to do for this one is post your answers to these questions, and then you're done with the PostLab. That is due by Saturday at 11:59 p.m. So those are the items that you have on your plate, that you had or have on your plate for this week. The momentum experiment that you're going to complete, the lab report for it is not due until next week. So again, I can't stress enough paying attention to the announcements and following the weekly overview, because it's set up to guide you through this course. If you do exactly what it says in the activities, then you're not going to fall behind. Okay, let me do this again. Here we go. All right. So for the momentum experiment, you have to go out to this simulator. It says click, you follow it, it says click the FET link right here, click play with Sims. Okay, Sims, physics, motion, and I'm just following the path that it tells me. And then I'm going to go find the collisions lab. So there we have it. Tells you click the big red F. It opens up. Okay. So this is the simulator, and you can play around with the various bells and whistles and get comfortable with how it works. that kind of thing. You can turn on sound if you want. Okay. Oh, I keep getting reset, done. Instead of play. All right, there we go. Play. All right. You could also have it show you some various items. Okay. And so, again, your task is to play around with the simulator, get comfortable with how it works, and then you're going to use the setting here, elastic collision, according to the parameters that it gave you, and utilize that setting to complete this portion of the packet on elastic collisions. Then you're going to go back to the simulator, set it on inelastic according to whatever parameters they gave you, and then use that to complete the rest of the table. And then answer the questions that are given in the handout. So that's basically straightforward with that. You use the experiment handout to guide you, simulator, and then if you go and look in the weekly overview for next week, oh, sorry, I didn't want to do that. I wanted to open it in another tab. There we go. Let's take a look to see. Tells you what goes in the lab report for momentum. So you have to write a full lab report. So again, experiment handout, simulator, lab report, and the completed handout goes here for data and analysis. So you do the completed handout using the simulator, then you write a lab report following this format. Any questions on that? Because believe it or not, at this late stage, despite how many times we've done this, I'm still getting questions from students about what do I put in the lab report, which means you're not following the weekly overviews at all. Any questions? Just unmute your mic and ask, no problem. All right, so that's pretty straightforward on that one. So working energy. So for this one, I've given you some specific directions here to follow. It says use the link here for the simulator. Okay, so if you click that link, simulator comes up. Okay, and then this simulator works. Again, you can, all the bells and whistles. And the way you get this to work is you take the skater and put them on the skate ramp. And then once you let it go, notice the skater goes back and forth. Okay. That's how the simulator works. To get the skater going, when they're here, you have to drag them onto the skate ramp. And notice there are markings here to tell you the various height values in meters for the skater. To play, it keeps track of the skater's speed. And you can see a gauge here that kind of gives you an indication of the skater's various energy values, kinetic, potential, and total. Notice when you're on the intro setting, there's no value given for the thermal energy because this is a frictionless system. All right. So now that you know how the system works, the simulator works, let's talk about what you're going to do with it. So I told you right in the weekly overview, do not worry about the Logger Pro items mentioned in the experiment handout. In several places in the experiment handout, you will see information on Logger Pro. Don't worry about that. Let me do something right quick because I forgot. It looks like I didn't link to the file that I wanted to. Bear with me for a second. I didn't upload it. Hang on. Let me do something right quick. I need to put a file there for you before I go into this because you won't be able to see it otherwise. Uh, Doesn't look like I saved it. Okay, let me just do this. I'm fixing something here for you. Just bear with me for a second because I want to be able to show you on handout, but the only way I can do it is this. Oh, I can do it this way. Just bear with me. I'm gonna grab it from another course. I forgot to upload it on your guys' site. Okay, there we go. And then upload. Okay. I'm making sure you have the file that you need for this. I had it linked as a picture, but for some reason, the way this thing works is I can't show you, I can't share my screen and show you pictures. I have to convert it to a PDF for it to work that way. So now we got what we need. Okay, so we'll have what we need here when the time comes. All right, so says open the simulation, and again, I gave you the link to open the simulator. Don't worry about the Logger Pro stuff. And it says grab a timer. So you're going to need like a stopwatch of some sort. Most cell phones have a stopwatch feature. You could use that. If you have like a wristwatch that has a stopwatch on it, that's fine. If you don't have access to that, you can go online and just download a timer app. And you can do it that way. But the main idea is you're going to need some way to keep track of time while you're doing this experiment. Okay, so part one, you're going to be dealing with conservative forces. And when you're in the intro setting, you're dealing with conservative forces. So it says play around with it. Make sure you get comfortable with the simulator and then answer these questions. Once you've done that, now you're ready to start collecting some data. And so they tell you that you're on the Earth, and that's important because we know what the value of gravity is on planet Earth, 9.8 meters per second squared. So that's what you're going to be using. Notice also it tells you how to read the scales. Notice on here, they don't give you any values or numbers for here, and they don't give you any numbers for here. But on the handout, it tells you how to read the gauge and how to determine what the mass of the skater is. Okay, so now it says put the 10 kilogram skater at 6 meters and start the timer when you hit play. So now here's the thing. You're going to be operating a stopwatch and this start and stop button. So this in some ways is like a two-person job. And if you have somebody that can help you by keeping track of the time, or this and you keep track of the time, um, that would be helpful. But if you're not in that situation, then you're going to have to work on your coordination to be able to stop both of them simultaneously. Okay. And I would say to you, don't beat yourself up too much if you're not exactly perfect, but try to stop them both at the same time as much as possible if you have to do this by yourself. Okay. So the way this works is you're keeping track of the time with the stopwatch. You're measuring the height and the speed. They say velocity here, but it's in essence the speed because we're not worried about direction. Okay. So those are the things that you're collecting. And it tells you you're going to do that for about 45 seconds. I would give it a minute just to be sure, just to be safe, you know. So you start this, and it tells you you're to pause both the timer and the simulator when the skater is at 4, 2, 0, and 6. The way you're going to have to do this is you let the skater start and you catch them when they come back to the left side. Do not try to measure the height or time or anything like that for the skater when they're on the right side. So you only make measurements on the return trip. Otherwise, you're going to run out of space in the table if you're trying to measure them on both sides. Okay? So it takes some getting used to the time, the simulator to catch them right at 0, 2, 4, and then 6, right? So you got to get used to how you stop it. So 0, 2, 3, 4. So it takes a little bit of practice to get a rhythm of stopping them. Okay. And I wouldn't like overly stress on if you're exactly at 0 or exactly at 2. The main idea is that you're going to be measuring the various positions for them wherever you stop it. So let's say I stopped it there. Well, I would be comfortable enough to say that's pretty much 0. And then you measure their speed and you measure the time on your stopwatch. And then you start them again. And let's say that's not quite 2, but let's say that's 1.5. I got the speed, I got the time. And so you're going to do that until you complete the table. Any questions on what you have to collect?
So how do we, like, I'm kind of confused on how we get the time.
You have a stopwatch. That's why I said you're going to need a stopwatch, right?
Mm-hmm.
A timer. You get the time from the timer.
So just click start and just stop it when it gets to 0 and whatnot.
Right. Whatever time is on the timer, when you stop it, that's what you record. And you measure the height and you measure the speed.
And we just start it anywhere.
You don't just start it anywhere. To start this, you put the skater up on 6.
Yes.
That's what it tells you in the directions.
Right.
So you start it here. But the question is, where do you measure the values that you have to put in the table? You measure those values when the skater is on the way back.
All right.
So I wouldn't measure the skater when they're over here.
And we fill out that whole table that you were showing.
Yeah,
All right.
because you're doing this for 45 seconds to a minute. So you're going to get enough values. So it's going to be whatever your time is, and it's going to be 6, 4, 2, whatever, 0, whatever, wherever you measure the height.
It
That's,
could be 1.5, all that.
yeah, that's what I'm saying. It doesn't have to be exactly 2, but
Uh,
wherever you pause it, that's what you write. But pause it on the left side. Don't pause it when the skater's over here.
all right. Sounds good.
Okay, that makes sense?
Yep.
Okay, great. Anybody else, please ask. I know this one is like a little bit involved, So, I could understand that you might have a question on what it is you have to do here. But what I always tell students is just slow down and read the instructions because they're basically telling you what they want you to do.
Alrighty.
Okay, so I'll stop them here, stop the skater here. So that'll take you through completing the table in step 5. Now here's where the next step in step 6 is where you gotta start doing some calculations, okay? So in step 6, it says, calculate the potential energy, kinetic energy, and total energy of the system using data from number 4. Actually, if you think about it, this is number 5. They got a number 5 here. It's not number 4, it's number 5. Because in step number 4, they're really just telling you how to read the gauges. So they meant step number 5 here. Okay? So you're going to use the data that you have in this table to do these calculations. Now the time part, that's just whatever values you had here. You're going to use the height to get the potential energy. How are you going to do that? So this is why this item was important that I wanted to make sure you had access to, because what I did was, and let me see if I can't shrink that down a little bit, just a little bit. Can you see that?
Yes.
Okay, good. Because the reason I had to convert the picture to a PDF was because they couldn't see pictures. But yeah, I'm glad you can see it. So I broke it down in terms of part 1 and part 2. So in part 1, this is the formula that you use for the first column. It says what? Potential energy. So how do you get the potential energy? Mass times gravity times height. Well, where does the mass come from? Well, they told you in the handout how to read the mass, right? It told you had 10 kilograms. And then this is how you read the speed gauge. So if you know the mass of the skater, 10 kilograms, you know gravity on planet Earth, and you know the height, then you can calculate potential energy at each of these heights. Whatever height you record, that's what you're going to use to calculate potential energy. And then it says kinetic energy. Well, how do you get the kinetic energy? Kinetic energy says 1/2 times the mass times the velocity squared. Well, where are you going to get that velocity from? Right out of your table up here. Whatever the velocity values you have listed, use them to calculate the kinetic energy. And then total energy. How do you get that? I tell you, total energy is equal to kinetic energy plus potential energy. So for every value that you have in this table, you should use it to calculate potential energy, kinetic energy, and then add those two together at every step and get your total energy. Do you understand how you're going to fill in the table in step number 6?
Yes.
You're going to use the formulas that I gave you. So I didn't take for granted that you know kinetic energy and potential energy, because for some of my classes is what I'm teaching this week. But for one or two of my classes, they're like a week behind. So they didn't have those, they didn't get to those formulas yet. So that's why I gave this handout. But if you follow it, you just use the formulas. Okay, it's pretty straightforward. All right. So now, once you finish with the table in step 6, here's where you get a little bit busy, or busier, I should say, because it asks you to graph the 3 data sets in number 5. It says using Logger Pro, but remember, you are not utilizing Logger Pro. When you do graphs for me, you have to do them by hand using graph paper and proper graphing technique. I will be looking to see on this experiment, but in particular, do you know how to do graphs? Okay, that's important. That's one of the major skills you're supposed to learn in this class. Percent error, graphing, and then information on how to write a lab report, and then doing some basics regarding measurement. Those are some some of the basic skills that you're supposed to learn from this class. And we're starting to get to the end now. So it's important that each opportunity that you have, you put your best foot forward to do these graphs. Okay. So how are you going to do these graphs? Well, it says 3 of them. What 3? Well, the first graph will be time on the x-axis, potential energy on the y. That's graph number 1. Graph number 2, time on the x-axis, kinetic energy on the y. And then graph number 3, time on the x-axis, total energy on the y. So when you finish step number 7, you should have 3 graphs. Okay? Do all of you understand that? Okay, I'll take the silence as a yes. Then you get to part 2 of this experiment. And this is where it tells you you're dealing with non-conservative forces. Click on friction. So let's go to the simulator. Now click on friction. And we'll turn on all the bells and whistles. Okay. And the skating process works the same. You start the skater at 6 and then let him go. And then you measure on this side. Stop them. Stop them. See, here's the difference now. Because there's friction in the system, the skater is not going to go back and forth like they did on the previous experiment. Okay? So you're going to have to collect data based on what you have, right? So when they ask you to fill in this table, well, the skater's not going to go for 45 seconds. So you record as many points as you can until the skater stops. And that's it. That's all you can do, right? But the process of collecting those points is the same. You got to catch the skater on the way back. So as close to 0 as possible, close to 2 as possible, and then wherever they peak out at, let them go, and then 0, 2, hey, whatever you can get, right? Now what you notice is, as this skater slows down, the kinetic and potential energy basically you lose all of that and gain it all in terms of thermal energy. If you're watching those gauges, watch. The skater starts out with all potential energy. That's the total energy that you have. And then as the skater moves, the kinetic and the potential energy get less, and less, and less. But as they get smaller, that thermal energy, heat, that's heat energy, gets bigger and bigger. And so that's what happens in a non-conservative system. You lose all of your mechanical energy, kinetic and potential energy, to thermal energy or heat. So now, of course, you know that you're recording the time, the height, and the velocity, and in step number 11, and then in step number 12, they're asking you to use those to calculate the potential energy, kinetic energy, and total energy of the system using the table, right? So the time values, whatever they are, I mean, you may not have that many, but list them here. Calculate the potential energy. And look, I gave you the formula again for part 2. Potential energy, mgh, kinetic energy, 1/2 mv squared. Now you got this new category now, the orange one, that wasn't showing up before in part 1. Now in part 2, you got to deal with that. So how do you get this thermal energy business? Well, I tell you, at any height, the total energy in the system, total energy, TE, total energy, that's this greenish, well, I guess, yeah, it's kind of like greenish looking value. Okay. It's not green. It's kind of greenish, I guess, value. That's your total energy. So at any point, if you add up your kinetic, potential, and thermal, you get the total energy. So if I want this thermal energy by itself, I have to take the total energy minus the kinetic plus the potential. So in other words, I did some algebra for you, and I got this last term, thermal energy, by itself here. Okay? So how do you get the total energy in this case? So for part 2, to get the total energy, use mgh, where h is 6 meters. So the mass, 10 kilograms, times gravity, 9.8 meters per second squared, times 6 meters. That'll give you your total energy value. That total energy value goes right here in the formula each time you want to get thermal energy. So slow down, pay attention to the formulas. It shouldn't be that challenging for you, because once you know this value in part 2, it doesn't change. It's just these values that are going to change. Okay? So once you have that table completed, guess what they ask you to do in the next step? In this next step, they ask you to graph all 4 of them. They say using Logger Pro, but remember, you're not using any Logger Pro software. So what 4 graphs? Time with potential energy, time with kinetic energy, time with thermal energy, and time with total energy. So 4 graphs. Okay, so for this energy experiment, since it's extensive, I did not require you write a lab report. For the energy experiment, you do not have to write a lab report, but you do have to complete the experiment handout, and you do have to have 7 different graphs. So it is extensive, but hey, that just means you got 7 opportunities to show me that you know how to do graphs. What are your questions on part 2? The data that you have to collect here, the calculations that you have to do using the formulas for part 2, the graphs you have to do for this table for part 2. All right, I'll unshare my screen. So if you have a question about anything I've covered or just a question in general, feel free to unmute your mic and ask. I'll be happy to address your question. All right, so if there are no questions, I'm going to stop the recording